Hello everybody, this is 3.3 day number 2. This worksheet is going to be utilized during work time, but I thought maybe I would go ahead and walk you through a couple of examples here in case you're not in class to ask questions. So the directions for this worksheet are to evaluate the given limit because it is a derivative, technically speaking. Okay, so the three things that we're going to do is we're going to determine the function that's being used, the point that the function is being evaluated at, and then find the value of the derivative. So, for example, if I had f prime at 5, that would be equivalent to the limit as h goes to 0 of f of 5 plus h minus f of 5 over h. And that's exactly what I have in problem number 1. So I've got f of 5 plus h minus f of 5. So what you want to do in order to find well, this is equivalent to f prime at 5, I need to know what f of x is. So instead of doing all the work of cubing this term and then simplifying and evaluating the limit, if I knew what f of x was, then I could find what f prime of x was, which would allow me then to find what f prime at 5 was, to skip all the craziness and all the work that you would have to do to evaluate the limit. So if I'm plugging 5 plus h into f, and that's equal to 2 5 plus h cubed, I got to imagine that f of x is 2x cubed. So if f of x is 2x cubed, then f prime of x would be 6x squared. So f prime at 5 would be 6 times 5 squared, which would be 6 times 25, which is 150. Therefore, this limit should be equivalent to 150. Okay, let's look at, oh boy, let's see here. Let's go to, why not? Let's just go to number 2. Okay, now we have replaced h with delta x. No difference at all. So it looks like I'm evaluating the derivative at 3. That's what this limit will come out to equal. So what would f of x equal? So it looks to me like f of x would equal 4x cubed. Therefore, f prime of x would equal 12x squared. So f prime at 3 would equal 12 times 3 squared, which would be 90, 108. Does that sound right? I think that's right. Therefore, this limit would equal 108. Okay, let's look at a slightly more challenging example. How about number 5? That looks good to me. Okay, number 5, you can see here that I've got the derivative being evaluated at, not 2, at 1. Okay, so I see it being evaluated at 1 and 1, and I see that f of 1 is equal to 6. Okay, so it looks like f of x will be equal to 2x cubed plus 4x. Okay, you can see it here. Whenever I see a 1 plus delta x, I consider that like x. So you can see that I would have 2x cubed plus 4x minus, this is f at 1. All right, so let's evaluate first by finding the derivative. So the derivative of f is going to be 6x squared plus 4. So the derivative evaluated at 1 will be 6 plus 4, which is 10. So this limit should come out to evaluate to 10. Okay, let's look at a couple more examples. Let's look at number 8. Okay, so number 8 is going to use different form. Notice that I have f of x minus f of a over x minus a, except now I have x approaching t. So this is the definition of the derivative of f at a. So what I'm looking for here is I'm looking for the derivative at x equals t. All right, that's what this limit will evaluate to. It'll be the slope of the function at x equals t. All right, so let's find what f of x is first. Well, if it's f of x minus f of a, I see that f of x will equal 2 over x, which I can write as 2 to the x minus 1, or 2x. 2x to the negative first power. Okay, it's kind of late. F prime would then equal negative 2 over x squared. Therefore, f prime at t would equal negative 2 over t squared. So this limit would evaluate to negative 2 over t squared. All right, let's look at one more. Let's go to number 10. And of course now we are in the original form, right, where we're looking for f prime at pi over 2. Okay, I can see my x value, and we're using delta x instead of h, which is fine. So I've got f of x plus h minus f of x all over h. All right, so what is f of x? F of x is sine x, and you may not know this yet, but the derivative of sine x is actually cosine x. So f prime at pi over 2 is equal to the cosine at pi over 2, which happens to be 0. Therefore, this limit would evaluate to 0. Okay, let's look at a couple more examples, and then we'll call it good for today. All right, example 11. Using a very similar process, this limit would evaluate and give us the value for f prime at 2. So what is f of x? F of x is e to the x. So the derivative of f of x is also e to the x. And we're locating our derivative at x equals 2. So we would then insert a 2 for x, and we would get e squared. That would be the value that limit would approach or be equal to as x approaches 0. All right, number 12. Which of the following expressions is the definition of the derivative of g of x, which is ln of x, at the point 2 ln of 2? Okay, so if I take the limit as h approaches 0 of f of x plus h minus f of x all over h, and f of x equals, or g of x in this case, let me rename it f of x so I don't commit a sin here, then this would be equal to the limit as h approaches 0 of ln of 2 plus h minus ln of 2 all over h, right? Because x equals 2 and f of x equals ln of x. So I'm searching now. Where am I? And it looks like I found my answer here. Okay, I'm not going to do your entire homework assignment for you, so I'm going to look at number 13, and then we'll call it good. Okay, so again, we're into the alternate definition of the derivative, and this limit represents f prime at a. So if I can identify f of x, which I can, square root of x, and I can identify then the derivative. Now consider that f of x is equal to x to the 1/2 power in that power rule form. Then f prime would equal 1/2 x to the negative 1/2, which is equivalent to 1 over 2 square root of x. So f prime at a would equal 1 over 2 root a. And there you have it. Your answer is a. All right, guys, that's just a little help on your worksheet. Hopefully the rest of it goes well. We'll see you in the next video.